Hi, we are going to talk about vector addition with angles. We have three vectors with angles that we are going to talk about and add them together in order to find where the resultant vector will rest. So the first vector we have here is 3 kilometers, 25 degrees counterclockwise. Counterclockwise on our compass here is actually going to go this way, around, and that's where we will find out where our vector will rest within that. So 3 kilometers, 25 degrees counterclockwise. I'm going to draw my arrows down here. So 25 degrees is somewhere in the middle of these two. So in between 90 and 0 degrees. So I'm going to make an arrow that kind of looks like this. Now we have number 2. 5 kilometers, 270 degrees counterclockwise. We notice that our southern bound degree is 270 degrees. So that's just a straight arrow downwards. It's going to be slightly bigger than our previous arrow to conform to the vector rules. And number 3, we have 4.24 kilometers, 321 degrees counterclockwise. So we have 270 degrees and 360 or 0 degrees on the eastern bound angle. And so it's going to be somewhere between there. I'm going to say that it is a little in the middle. So I'm going to kind of do a line that's a little smaller than 2, but to the angle like that. Now, each of these have a uh, component that is going to mimic its direction. So this first arrow actually goes north of east. So we have an eastern bound line and a northern bound line like that. Our second one is really just south. So we don't really need to do any triangulation there. Our third one is going to be south of east. South of east. So we're going to use this table down here, this big old table, and we are going to find out what exactly is the x coordinate and the y coordinate for these dotted lines here in order to sum them all up, add them together, and find our resultant, whatever, let's say number 4. So 3 kilometers cos 25. We are in the second column of our table. So 3 cos 25, we get 2.72. Okay. And we are going to put all of that into kilometers. And we are going to say that this is going, because this is our x coordinate, we're going east. Because our arrow here, it's pointing, number 1 is pointing north and to the east. So this is going to be our eastern bound coordinate. Now this will be our northern bound coordinate, the y coordinate, 3 sin 25. And we get 1.26. Actually, we'll do 1.27 kilometers north. This will all make sense when we start adding these together. So now let's start crushing through these arrows here. We have 5 cos 270. And as you can see here, this is actually 0 kilometers. And because this is our x coordinate, we really don't need to write east or west there because it's just 0. There is no directive to it. And we have our y coordinate for number 2, which is 5 sin 270. And we actually get, and did that actually give me the answer? Oh no, it's -1. -5 kilometers, which makes sense. -5 kilometers south. So that's kind of nice that you get to see an exact kilometer for that arrow. So there is no triangulation. It's just a direct kilometer south. Let's go to number 3. So we have 4.24 cos 321. 4.24 cos 321. And we get 3 let's do 3.3. We'll do 3.3. No, that's not the answer. 3.3 kilometers. And let's look at this. It looks like it's going south of east. So number 3, just to refresher, if this is our compass here, and this is east, and this is south. This down, this x coordinate is going to be going east in order to get to that point. So it's going to be going this way to get to that arrow point. So it's going to have to go east from that coordination. So we have east here. And finally, this last one, of course, will be south. We have 4.24 sin 321. And we get a negative 2.67 kilometers south. And we can actually erase those negatives because we are going to compare them with we're gonna know what to do when we start adding these vectors together. Okay, and we're gonna do that below. Actually, let's do it above. We'll do it in this region over here. So let's add these vectors together. So if we take everything in this x coordinate here and add them together, we have east, east, and 0. So it's just going to be 2.72 plus 3.3. So we get a resultant arrow that's going to have a 6.02 kilometer east vector. Now the y coordinate we have to add up, and we get 1.27 minus, let's actually do this, 5 plus 2.67 minus 1.27. And we're going to get a 6.4 south. Kilometers south. Okay, so we can start coordinating that angle, and we'll actually put that in our box here. So we are going to have an angle that's south of east that is 6.4 and 6.02 kilometers. So to write this in, we have to do a resultant using Pythagorean theorem. Okay, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. So if we wrote this out, say we actually wrote out these two vectors, we have a 6.02 east, 6.02, and we're going to be squaring that. And we also have a 6.4 squared here. It's going to then be equal to c squared, or the resultant here. So to write this out, 6.4 squared plus 6.02 squared equals c squared. We are going to square those here. 6.4 squared plus 6.02 squared. We get a resultant of 77.2 equals c squared. We need to square root each side in order to eliminate that square. So 77.2 squared, 77.2 is going to be equal to a resultant of 8.79 kilometers south of east. Okay, so our resultant is going to be an 8.79 kilometers south of east. Now, in order to get this, let's actually write this out. So 8.79 kilometers south of east. And actually this arrow would have been over here, not there. There we go. So it'd be that hypotenuse. So number 4, we actually have a very large arrow here. Okay. Now we need to find the angle of this, and we're actually going to pull a tangent an inverse tan utilizing our 6.4 and our 6.02. So we're going to go back to this area over here, and we have our 6.4 and our 6.02 here. Now our angle that we are trying to get is going to be right here. Okay. And what we need to use is the SOHCAHTOA, and SOHCAHTOA is this, and we're actually going to be using the TOA. And what does that mean? We're going to use inverse tan to get the opposite and the adjacent angles. So the adjacent angle is going to be, so if this is our theta, our adjacent angle is going to be right here, and our opposite angle is over here. So we need to take the 6.02, that is our adjacent, and divide it, let's see here, or I'm sorry, we're going to take our opposite angle, 6.4, and divide it by our adjacent angle. So we have inverse tan of the division that we are going to use of 6.4 divided by 6.02, and that will give us our angle for our resultant. So 6.4 divided by 6.02, and we get a final angle of 46 degrees, which is now another scenario that we need to write out. So because it is south of east, and it is in that fourth quadrant, the fourth quadrant is right here. So if we have 1, 2, 3, 4, it is in that fourth quadrant. So we are actually going to add 46 to 270. So 270 plus 46, and we are going to get an angle of 316. So this angle here, this theta for number 4, is equivalent to 316 degrees. Okay, so that is the resultant of 3 different angles going into, or 3 different vectors with 3 different angles going into our final resultant vector with a degree that follows it. I know this was confusing, so I will be doing a couple of these videos and maybe even catch some of my mistakes along the way. Thanks for watching.